Welcome back, scholars, to the back end of our unit on functions, more specifically transforming them. It feels like it's been quite some time since we've been here. Today, we're going to be looking at how to stretch and compress functions, or I should say today and the next video, um, both using their inputs and outputs. For this lesson specifically, we'll be learning how to transform the output of a function to fit data. So I can describe the effect of a scale factor on the output of a function. I'll know I've got it when I can calculate the scale factor needed to transform the output of a function to model data. All right, to start, we have a notice and wonder. Try to look at it from a mathematical perspective, but still have some fun with it. What are some things that you notice? What are some things that you wonder? This is the home arch, I think, located in Minneapolis, Minnesota, but don't quote me, or it might be in France. Two completely different continents. Over two. The home arch bridge in Manchester, England is shaped like a parabola. The ends of the arch are 52 meters apart, and it is 25 meters high. Use the description to help you label the three coordinates on the graph. I'll make sure that you have the ability to label them, since for some reason that was taken away. But Han wants to model the shape of the arch with the graph of a function, and he chooses this function, where h of x is the height of meters above a point x meters along the base of the arch on the left end. You can read. For the x-coordinates of the 3 points, what are the corresponding points on the graph of h? So using, obviously, our visual to the left, right, taking those x-coordinates and substituting them into this function here for h of x, fill in this table. And below in the text box, just describe what aspects of the shape does Han's function model well, and what parts does it not model well. You should be able to very quickly determine one aspect that it does not and one aspect that it does. And in using that information, how can we change the outputs of h to make it fit better? So basically, how can we modify our function of h? And this is where we're going to need to require the use of a scale factor, so which is a numerical value that is greater than 0 that will change the vertical orientation of our graph, and then input your function that you've created. Now for the back end of this activity, it's going to be rather straightforward. Okay, so we have some graphs here, and we're just going to use algebraic notation to describe how to transform the black function into the red function. I will assist you with this first one. We can see that our values here for the horizontal component are 2, and then they raise to 4. And it seems like, all of the corresponding outputs for each input are doubling in value. So this function is nothing more than 2 times the function. So using that type of thought process, determine those two algebraic transformations that I've just clicked past, and in your own words, describe the effect of a scale factor k on the output of a function f. We consider y equals k times f of x. Try to be very specific, because as we can see here, not all scale factors are the same, if you get my movie reference. And that's where we'll pause for today and pick up in class with the enhancement opportunities.